Here we are again. So we're looking at section 4.5 again with integration by substitution. And today we're going to focus in on trig. I got rid of that part there, so we're just going to look at trig today. And the things that we want to remember are our integration rules for our trig functions. So we know these from the past. We'll go over them again real quick. Integration of sine is negative cosine. Secant squared is tangent. Secant tangent is secant. Cosine goes to positive sine. Secant squared is negative cotangent, and cosecant cotangent is negative cosecant. All, of course, plus c. Don't forget that c as we do it. So we've talked about integrating, and we've talked about the composite function and how that plays into integration. So as we do our trig, now as we do our u substitution, we're going to generally, and again, this is generally, we're going to start by letting that u be the angle that we're taking the trig function of. So as I look at x cosine of x squared, I can think of this as the composite function of the cosine of a function. So I'm going to let that angle be that u. So as before, we're going to find the derivative of this because I'm going to need that. And the derivative here is 2x dx. As I look back at my integrand, I have an x, I don't have that 2. So I'm going to go ahead and divide both sides by 2 to get 1/2 du equals x dx. That I can go ahead and do my substitution with. So my x dx is coming out, my 1/2 du is going in, and my cosine, I'm not doing anything with the cosine, but the x squared is going to be my u. So I'm going to have the cosine of u. I can go ahead and bring this 1/2, since it's a constant being multiplied to the cosine of u, to the outside if you want. Some people like to see that as a nice clean integration or integrand there. So we have the cosine of u, and the integration of cosine of u is the sine of u. So I have 1/2 the sine of u. U is actually x squared, so I think we can go ahead and do all of that at one time there, and then plus our c. And that's going to give us our answer. Here we have the integration for our second example, secant of 3x, tangent of 3x dx. So again, secant tangent, I know the integration of secant tangent. That's my secant, isn't it? So if I can get this down to a single variable, then I can go ahead and find that integration. So I'm going to let my u equal 3x, which is going to be, again, that angle. So du is going to be 3 dx. I can't use the 3, don't have a 3 in there, my integrand. So I have 1/3 du equals dx. So now I'm looking at 1/3, since we have 1/3 times all of our integrand, we can bring that 1/3 out, of secant of u, tangent of u, du. And again, we know the integration of secant tangent, that is going to be the secant of u. And then plus our c. We can go ahead and replace our u with our 3x, and there's going to be our answer. So we get 1/3 the secant of 3x plus c. So fairly straightforward, I think, at this point. One more nice clean one here, I guess, before we get into some trickier looking ones. What happens if we give you the 3 sine of 4x? So again, I'm going to let my u be, again, that angle, 4x. And then we can go ahead and take the derivative of that. So we get du equals 4 dx. Can't use the 4. So we're going to have 1/4 du equals dx. Notice with this one, though, we have that 3 out there already. So we're going to bring this 1/4 and we're going to multiply it to that 3 to get 3/4 the integration of sine of u du. We know the integration of sine of u, that's going to be negative cosine. So we bring that negative all the way out to the outside with my 3/4. The cosine of our u is actually 4x plus c. So I'm doing a little bit of work as I replace or take my integration and I go ahead and replace my u. If you want to step that out, by all means, there's no reason why you can't. So here we have the sine of 3x, cosine of 3x, integration dx. So again, if I let my u equal 3x, here du is going to equal 3 dx. Can't use the 3, so I have a 1/3 du equals dx. If I do my integration, I'd have 1/3 the integration of the sine of u, cosine of u, du. And as I think about it with that, I don't have a integration of the sine of u times the cosine of u. So that's a little bit of a problem for me. So we may have to actually go back and rethink what our u value is. Remember, u can be whatever we want. So in this case, maybe I'm going to go ahead and change our u. Well, if I think about sine or cosine, I know the integration of cosine. Integration of cosine would be, sine. And the integration of sine, that would be, yes, negative cosine. So I'm going to let my u be one of these trig functions. And we're talking in a second which one we're going to pick, or maybe if it doesn't really matter. So here, derivative, if I let u equal the cosine of 3x, then my derivative of cosine, is negative sine of my angle, 3x, times the derivative of that angle, isn't it? dx. Remember, don't forget to take the derivative of that angle. Most common mistake when you're doing derivative of trig functions. So we get negative 3 sine of 3x dx. And notice I have a sine of 3x dx in my integrand up here, don't I? That's interesting, isn't it? So, what do we got then? Well, we have negative 1/3 du equals the sine of 3x dx. Well, if I go ahead and do my integration then, I get negative 1/3 the integration. My sine 3x dx becomes negative 1/3 du. And the cosine of 3x, I let that be my u. So here I got the integration of just u du. Integration of u is u squared over 2 plus c. Now we can go ahead and replace our u and clean this up a little bit. So we get a negative 1/6 of u squared. U squared is actually the cosine of 3x squared plus c. That don't look too bad, does it? Well, some of you are probably asking, well, wait a minute, how did I know to let u equal the cosine of 3x? What if I let u equal the sine of 3x? Would it change the answer? So here our du would equal, the derivative of sine is cosine of 3x times the derivative of the angle, which is going to be our 3, dx. Again, I have a cosine of 3x, don't I? So I get a 1/3 du equals the cosine of 3x dx. So I'd have the integration then of 1/3, or 1/3 the integration of u du. That looks pretty familiar, doesn't it? That's what we had up here, except for we had a negative, and here we have a positive. So here we have 1/3 times our u squared over 2 plus our c, where u is the sine of 3x. So I get 1/6 the sine of 3x quantity squared plus c. Notice we get two different answers. And some of you are probably scratching your head there and saying, well, what do I do? How do I know which one's right? Well, they're both correct, aren't they? Do they equal each other? So that's going to be actually the question we're going to ask. Are these two things equal to each other? Is negative 1/6 the cosine of 3x squared plus c equal to 1/6 the sine of 3x squared plus c? We have a little verification problem here, don't we? Yes, we do. So we can change one side to the other, or we can change one side and we want to make it look like the other. So are these two equal each other is what I'm asking. Well, what do we know about cosine squareds and sine squareds? From your wonderful days in pre-cal, we know the Pythagorean identity of sine squared plus cosine squared equals 1. So I can go ahead and take cosine squared, subtract my sine squared over to get cosine squared by itself. So we get 1 minus the sine squared x. Doesn't matter what our angle is, it's always going to work for us. So we can replace that 3x with x if we want. So what does that mean? Well, it tells us that negative 1/6 of 1 minus sine squared of 3x is squared, I get squared there, plus c is going to equal that. If I multiply my negative 1/6 through, I get negative 1/6 plus 1/6 of the sine squared of 3x plus c. Well, are those two equal to each other? Well, they're very similar, aren't they? We've got that 1/6 sine squared 3x that we want. This plus c we have this negative 1/6. Remember, negative 1/6, that's a constant, isn't it? So we have a constant plus another constant. And we've talked about this idea, and we will continue to talk about this idea of c being very fluid. It means it's going to change quite a bit for us as we do problems. So if we take that negative 1/6 and combine it with this constant, a constant plus another constant will simply give us a constant. So we get 1/6 of the sine squared of 3x plus c is going to equal this value here. So they are the same. So they are, yes they are, yes they're equal, aren't they? So we go back to, which one do we do? There is no wrong answer, there's no right answer. However, if it's multiple choice, you may get either one of these answers. They won't give you both answers unless they ask you which select all that would apply, sort of thing, but they generally don't do that with this type of question. So you would have to use your trig identities to get from one version to the other. So a little bit of fun there, and a little bit of fun from our trig days. All right. Oh, there we go. I had to focus it in there on you. All right, so here we have one last one, integration of the tangent of x cube root times secant squared of x dx. So what do we let our u be? Well, if we recall, if we had a quantity, and I could write this as the quantity of tangent of x to the 1/3 secant squared of x dx, I could write it in that fashion, couldn't I? Change that radical to a fractional exponent. So then my u would be that quantity, tangent of x. And again, we could try some other things. We don't necessarily know 100%, but I got a pretty good idea, since we have a quantity to an exponent, that my u is going to be what's inside that quantity. And I just also happen to know the derivative of tangent x is secant squared of x dx, isn't it? So here I've got my integration, exact substitution. So I'm going to replace my tangents with u to the 1/3, and my secant squared x dx goes to du. Integration of u to the 1/3 is u to the 4/3. Divided by 4/3 is the same as multiplying by 3/4 plus our c. We're going to go ahead and replace that u with the tangent of x to the 4/3 plus our c value. And that gives us several examples of our trig and how we could see different things applying. Generally, we're going to allow the u to be our angle, but in some cases, like that sine of 3x, cosine of 3x, we may have to let it be a actual trig function. So play around with them. The first way doesn't work, we try something else. Good luck, enjoy. If you have questions, let me know.